To do mathematics, we need to somehow represent the math we're doing. Just like how we need complex language to think and converse about concepts, we need words and symbols in maths. Whether that be counting the fingers on our hands, heaps of stones on the ground, etches on a bone, or abstract, symbols, we need to have a system for understanding the maths we're doing. At first, all we had was sign language, counting the fingers on our hands 1, 2, 3, 4, and 5, the digits to describe groups. When 5 on a hand wasn't enough, we extended it to 10 on the other, then 20 with our toes. When our digit became inadequate, we piled heaps of stones to talk about large numbers of things. However, the quick use of our fingers to count caught on. The widespread use of the decimal system, base 10, comes from the fact that we have 10 fingers and 10 toes. Quinary systems, base 5, were also developed. These together became the primary bases, taking over binary, base 2, and ternary, base 3. The decimal, base 20, was also common, which can be seen in the French 80, literally 4 20s. There's more evidence in our etymology of different counting systems. For example, linguistically, 11 and 12 may mean 1 over and 2 over 10 that is. Also, the numbers 13 to 19 very clearly mean 310, 410, 510, and so on. There is also evidence that 8 is derived from a dual form of 4, that novum, Latin for 9, is derived from novus, meaning new, as in it's the beginning of a new sequence. This also supports quaternary, base 4, or octonary, base 8 systems. However, some of the earliest civilizations, Sumer and Babylon, used a different system for counting. They used a sexagesimal, base 60, number system. They counted 12 knuckles on one hand by 5 fingers on the other. 60 is also the first number divisible by all integers 1 to 6, making it easier to factorize. In fact, sexagesimal and similar bases are still in use today. In clocks, in degrees of rotation, initially in the number of days in a year, number of months in a year, and inches in an imperial foot. Roman numerals are a special kind of base system. It's additive and subtractive instead of using place values to inherently multiply symbols. The classic Roman numerals use I for 1, V for 5, X for 10, L for 50, C for 100, D for 500, and M for 1000. To calculate something written using Roman numerals, all you need to do is add all the numbers on the right of the largest values, then subtract the ones right before a numeral greater than it. They also place the horizontal line on top of each numeral to denote multiplying by 1000. Nowadays, we use the decimal system and the Hindu-Arabic symbols of 0 to 9. However, we also use different systems for different purposes. We use base 2, binary, for computers. We use base 16, hexadecimal, for colors. We use base 64, tetrasexagesimal, for encoding large numbers in, for example, website links. There are also new base systems used for naming things that are inherently decimal biased, or because their creators find something inconvenient with base 10. The most common base system to prefer over decimal is base 12, duodecimal, or dozenal. This is due to 12's easy factorization into 2, 3, 4, and 6. Perhaps it would have been better if we spawned with 6 digits a hand.